In this video, we're going to look at graphing linear functions, and we're going to be doing so with slope-intercept form. And so the essential question is how do you graph a line using slope-intercept form? Okay, and the biggest thing to take away initially is just what is slope-intercept form. So this is y equals mx plus b. You need to say that a lot. You need to write it a lot. You need to memorize that. The slope is the m. It's the number that's multiplied by x. And the b is the y-intercept. The biggest thing with this is first you have to solve for y. So if you get y by itself, if it's a line and y is by itself, it is in slope-intercept form. And so if you solve for y, then the slope is just the number in front of x, and the y-intercept is the value here. And then we know slope is rise over run, and so we can use that fact to graph the line. But first, let's just look at identifying the slope and y-intercept. So first, you want to solve for y. And if it's already done for you, you can just say slope is 5 and y-intercept is -3. And we'll use m for slope and b for y-intercept. Or you could write the y-intercept even a better way as 0, -3, because it is a point. This one's kind of tricky, y equals -2. So what is the slope? Well, there's no x there, so that means the slope is 0. Because this would be y is equal to 0x minus 2. And then the y-intercept is -2. You can also think of this as a vertical line where y is always, a horizontal line where y is always -2. See, we have a little bit of work to do. We need to solve for y. So let's subtract 3x from both sides. And then divide everything by -3. We'll show that step. And that gives you y is equal to x minus 4. So your slope is 1 and your y-intercept is -4. X equals 5. This one's tough. It is a vertical line. 2, 3, 4, 5, where x is always 5. So it's a vertical line. There is no y-intercept. And the slope, you go up, let's say 5, and then over 0. So you do rise over run would be 5 over 0 or something over 0, or the slope is undefined. So the slope is undefined. It is not 0. This is if y equals has a slope of 0, x equals has a slope of undefined. And there is, in this case, there's no y-intercept. Okay, and then on C, we need to solve for y, so let's subtract x from both sides, and we'll write that out. And you get 4y is equal to -x plus 6, and then divide everything by 4. And so y is equal to -x over 4 plus 3 over 2 when you reduce. Okay, this can also be written, sometimes the x being on top throws people off. With x plus 3 over 2. One way is not better than the other. It's just a different way to represent this fraction. And so the slope is -1/4, and the y-intercept is 3 over 2. Okay, and here are the steps for graphing these. So we're going to do what we just did, rewrite in slope-intercept form, identify the slope and y-intercept, and then we're going to plot the point that corresponds to the y-intercept. And then we're going to count our rise over run, and draw our line. Okay, so y equals 3x minus 2 is already in slope-intercept form. So the slope is 3, or if you want to write it as 3 over 1, that's good. And b is negative 2, so the y-intercept is 0, negative 2. So that's your starting point, your y-intercept. So go to your y-intercept and start there. Put the point there. And then I would even like pick your pencil up and then put it back down and then think about the slope. So slope is rise over run. So it's 3 over 1, which is up 3 over 1. So from your y-intercept, make sure you're there, go up 3, up 1, 2, 3, and over 1. And if you want to do that again, you can, up 3 over 1 to give yourself multiple. And use a straight edge. I kind of missed on my line, but your line should go through. Oh man, it's getting worse. Your line should go through all the points. You really only need 2 points. If you want to use another point to check, you can. So that would mean like if I plug in 2, I should get 1, 2, 3, 4. So you plug in 2 here. 3 times 2 is 6, minus 2 is 4. So that checks out. Okay, on the next one, my slope is negative 1 or negative 1 over 1, and my y-intercept is 3, so that's the point 0, 3. So start 1, 2, 3. Start at the y-intercept. Start at 3. It's very important to use that as a starting point, and then count down 1 over 1. So down 1, right 1 would be negative. Also, you could go up 1, left 1 is the same thing. Let's see if I can draw this one a little better. And then draw your line. You should also always check your work. This slope is positive, so the line should be increasing from left to right. This slope is negative, which means the line should be decreasing from left to right. It's really easy to switch those when you're plotting points or forget about it, so it's good to just take a step back and look at it and make sure it's good. Now, these two equations are different, y equals and x equals. And there's 2 ways to approach these. One is just memorizing, but it's pretty tough. But if you can remember y equals is a horizontal line, then that's all you got to know, right? It's a horizontal line through negative 5. The challenge there is the y-axis is a vertical line, so it's a little bit counterintuitive that they're the opposite. Another way is to make a table. If you see this, think I'm going to make a table. Or you can just think, okay, y is negative 5, and just find some points where y is negative 5. So y is negative 5. 1, 2, 3, 4, 5. Go down to negative 5 and put a point. And then I usually use the point negative 5, negative 5, right? So go on the y-axis where it's negative 5, and then go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so just repeat it. And the reason why you do that is if you put negative 5 in both spots, like you can't really mix, or it's not as easy to mix up your x and y. And so now you have this horizontal line, and that's your graph. But you can put as many points as you want. You can do 1, negative 5, 2, negative 5, as long as y is always negative 5. If x is 7, you can memorize x equals is a vertical line. Or just think, okay, where's x7? 1, 2, 3, 4, 5, 6, 7, and there's a point. And then maybe you can think, well, okay, so x is 7. This would be 7, 1, 7, 2. Or just think about the point 7, 7. Where would that be? Well, over 7, 1, 2, 3, 4, 5, 6, 7. If I counted right, there's 7, and we have our vertical line. But the vertical and horizontal lines are tricky. Okay, here's a few more. Pause the video on your own, and then we'll go through them kind of quickly. E has a slope of negative thirds and a y-intercept of 0, 3. So go up 1, 2, 3, and then you count down 4, right 3. So down 4, right 3, and that's a point. If you want to do another one, 1, 2, 3, 4, 1, 2, 3. There's another point, and your line should go through all the points. The slope was negative, so the line should be going down. we did something right at least. Here the slope is 2 over 5, and the y-intercept is 0, 0, because there is no b value. So we just put a point at 0, 0. That's my starting point. Remember to start there, and then count up to 1, 2 over 5. 1, 2, 3, 4, 5. Now, especially if you are using, and then connect those two points with a straight edge. If you don't have graph paper, make sure you're putting tick marks on your paper. Don't just put points in space. You need tick marks so you know that you've counted exactly up to and right 5. Okay, these next two have a little bit of work to do. We'll show some work down below. So let's subtract 6x from both sides. So that gives us negative 3y is equal to negative 6x minus 9. Notice those can't go together because one has an x and one does not. And then divide by negative 3. And divide everything by negative 3. Don't forget both terms. So y is equal to 2x plus 3. And you can think of this as 2 over 1. And then 0, 3 is your starting point. So 1, 2, 3, put that point there. And then I'd say, like, pick your pencil up, like deep breath, and then go back. So that's my starting point. What's my slope? Slope is 2 over 1. So go up 2 over 1, up 2 over 1. And then use a straight edge to connect those dots. Remember that line extends forever. And you could count down 2 and over 1. Okay, down here we had a positive slope, and our line is increasing, so we feel good about that. And then here, let's add 2x to both sides. Remember, we got to get y by itself. And then divide everything by negative 5. And really watch your signs when you divide. So y is equal to negative 2/5 x plus 2. Now, a lot of people say, well, why this was 2 over negative 5. Why is it now negative 2 over 5? Because it's just a fraction. That negative sign can move from top to bottom. The whole fraction is negative, so that means either 2 is negative or 5 is negative. It's negative 2/5. So typically we'll put it on top. Okay, so that means my slope is negative 2 over 5, and my y-intercept is 0, 2. So we start with our y-intercept. Put that point there, pick your pencil up. Okay, now I got to think about slope. From my starting point, I'm going to go down 2 and over 5. 1, 2, 3, 4, 5. And you can keep going or connect those with a straight edge or draw as straight a line as you can. Okay, now we'll look at a couple problems that are a little different. So parallel lines have the same slope. So let's write just the same slope. So there's a couple ways we could determine if these points are parallel. One, we could use a slope formula, or if these lines are parallel, because we have 2 points. But we have this nice graph, so it's probably best just to count rise over run. So we're not going to do the slope formula, but it's a good idea to know it. y2 minus y1 over x2 minus x1. But let's just try counting. So let's start with this line, and we'll count here to here. So this would be down 1, 2, 3 over 1, 2, 3, 4. So the slope here is negative 3/4. We're going down and to the right. Okay, now let's look at this line. And once again, because we have this coordinate plane, let's just try counting. So if I go down 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. So this is down 3 over 6. So those are not the same. This is negative 1/2. This is negative 3/4. So lines B and C, which is kind of hard to see, but that's a B and a C. Those lines are not parallel. Okay, so let's look at this last one. Let's see. Just use green again. So if I count down 1, 2 and over 1, 2, 3, then the slope here is negative 2/3. So it looks like none of these lines are parallel, which is fine. That's possible because none of them are slopes. So if there is no solution, you can say none. That's a symbol for no solution. But they all have different slopes in this case. Okay, and then pause the video and try this last one. And then we'll take a look at it together. So one thing, get comfortable reading, right? And sometimes the reading is a big part of the problem, and sometimes it's just kind of there as a distractor, and it's not totally, excuse me, necessary. In this case, it does give you context. So a violin teacher charges a one-time sheet music fee of $20 for adults and no fee for children. The charges of $20 per hour and is the same for both children and adults. The total cost C for children of N lessons is given by this, and adults is here. So we're going to graph the equations on the coordinate plane, and then we want to know what is the difference in the cost for children and adults. Okay, so let's take a look at these graphs, and let's say we'll put lessons down here, and then we'll move that up so you can see it, and then we'll put the cost here. And let's go by 10. So 10, 20, 30, 40, 50, 60, and so on. And so we can graph this because both of these are solved for y or solved for c. So here the y-intercept is 0. And for every lesson, it goes up 20. Or we have a slope of 20. And this is for children. We use C equals, we'll write it down here. And we can just continue on with this line if we can make it straight as possible. And so there's the cost for the children. For the adults, we'll use a different color. C is 20N plus 20. So the y-intercept is 20 now. But then after that fee, there's no additional increase or difference. We're still now for one lesson, we're going to go up 20. If I pay another lesson, it's another 20. Another lesson, another 20. So I'm going up at the same rate. My difference each time is 20. So if I look here, if I do 0 lessons, well, 0 lessons, you wouldn't charge anything. But if there's one lesson, we would have a fee of 40 for an adult and 20 for a child. And then go up to the 2 lessons, 60 for adults, 20 for a child. So each time the difference is 20. So the difference in cost is $20. Okay, good luck graphing equations, and reach out if you have any questions.